Howdy once again, it's Tubalcain, your YouTube shop teacher, and welcome back to part 5 of the STUART Progress Steam Engine build. And this is how far I have progressed. Go back and watch the first 4 parts if you're new to this and just tuning into this particular part. There'll probably be 8 or 10 parts in all. Now the cylinder is missing here because it's over in the closing lathe 4-jaw chuck where I left off yesterday. So let's walk over there and see what it looks like. Here I am with Adam Booth, A-Bomb 79. If you haven't seen my recent video of my visit in Pensacola with A-Bomb, be sure and check that out. What a good day we had together. Alright, what I need to do here is to face the cylinder just enough to clean it up. There are no dimensions on the length of the cylinder, so facing it will do. Well, that cleaned up just nice. Now I'm going to use a starter bit and then a pilot bit, a 1 size under 1/2 inch drill bit, and a 1/2 inch reamer. And now with the pilot bit all the way through the cylinder. And 31/64 all the way through. And here's my 500 thousandths, that is 1/2 inch chucking reamer, all the way through. Just a real quick thought. Save your nickels and dimes so you can buy an extra 3-jaw chuck for your lathes so that you can keep one fitted at all times with the regular jaws and one with the reverse jaws, and avoid the aggravation and disheartening job of changing jaws. I'm over on the Atlas lathe now, and I'm facing the other end of the cylinder, and notice how I'm holding it. I'm holding it in one of these arbors that is expandable near the end. This is a larger one. I got the 1/2 inch one in there, and just tighten it up with an Allen wrench, and hopefully it won't spin. Well, it won't, because I already took a couple cuts, and now I'm just going to take 1 or 2 as a finishing cut. This assures that this end is perfectly square with the bore. Boy, that lathe is noisy. This is how I was holding. It's loose now. That was the first side, that's why I marked it. That's the first side that I faced off in case I need that for reference later on. Mark things if you have any question. Now the next thing I'm going to do is to mill this off. I'm going to the milling machine, so I will hold it by these two ends now, which I know are parallel and square and true and machined and all that other good stuff. Well, again, there's no dimensions on this, so I'm just going to clean it up. And when looking at the drawing here, you can see that there's really no similarity at all between this drawing and this casting. So I'm a little disappointed in that. I almost think that there was another set of drawings that they didn't send me, because I can't imagine a novice machinist working their way through this. But you can see that I need this pivot hole here, and that is going to be drilled and tapped because I don't think Loctite would hold it. And then while I have it in there, I'm going to drill the two ports as well, and there's the dimensions for that. Those are 3/32 holes, and they're 13/16 on center, and I can do that all in one setup, and I do not need to lay it out on this because I will use the digital readout. So I'm going to go over to the Bridgeport now and set this up, and we'll take a look at it. I was over at the Bridgeport, and then I came back because this thing just defies being held, and to determine if the sides are perpendicular to the vise over there on the mill, or and the top is so irregular, so I can't use that. So I'm using this handy little tool maker's vise here and just gripping it lightly. And you know, I'm like A-bomb. You know, I wonder who Jake Ranger was, what kind of machinist he was. Smart guy. He used Lufkin tools. So using this little die maker square, I'm kind of squaring it up right here on the casting as best I can, and then using a height gauge, I'm going to scribe it right here. Now that doesn't mean that I have to mill it down to that line, but that gives me a visual reference when I set it up in the Bridgeport vise. You'll see what I mean when I get over there. As again, I have no idea how much to take off of this. That's just going to be a guess. The work is clamped securely, and when I move in, I think you can see the little scribe mark that I just made at the bench, and I held a parallel, which is just my rule, up to assure that that line is parallel with the vise. Now, using a 1-inch wide cutter, because I wanted to use a cutter that's the full width of the work, I don't want to take two passes. This needs to be a nice, smooth, true surface, because that's what it oscillates on. So let me clean that up. Did you see a few sparks there? I either got a dull bit or I'm not through that fire scale. So I changed the depth, increased the depth. Now I still got sparks. I got a bad cutter, so I'm going to change cutters. Well, that was a bit of a fiasco. I ran into another dull cutter, or there are hard spots in this. So let that be a lesson to me and those of you out there, that when you identify bad cutters, throw them away right away. Don't put them back with your good tools. But I'm using this 2-cutter carbide cutter. It's, well, it must be 1.25 inches wide or so. And that's cutting through all the nonsense quite nicely. And that's leaving a nice finish, and that will be my last pass, I believe. Yes, it's cleaning up. That's the cutter I should have used in the first place. Now that this surface is trued up, I'm leaving it in position there, and I did some layout. And this is what it looks like. I have to drill and tap the pivot hole right here, and they say 1/8 inch Whitworth. I don't even know what that is. I'm using 1/8 inch, I should say 540. So I'll drill and tap it, and then the two steam ports, which I have not laid out, but they're on the same center line, they are 13/16 on center, which means that they are 13/32 on each side of the pivot hole. And I have done the layout with my little square and even center punched it. And I'm going to use a wiggler to locate the position here, lock the table, zero out the DRO, and drill that center hole. And let me emphasize how important it is that this particular hole be perfectly perpendicular with this surface. Alright, I've located the center of the spindle over the center of my little center punch hole using the wiggler. Now I'll take the wiggler out and put a number 38 drill into the chuck. Well, I'll start with a center drill, then a 38 drill, and I'm going to drill 5/16 deep. I do not want to drill into the bore. So I've got about 3/8 of an inch altogether, so I'll go in 5/16 inch. You know, lay out your tooling again, write yourself notes. You don't want to miss drill. You don't get a second chance at this. That's the problem when you're working with expensive casting. So next I will center drill, and then I will put the spring-loaded tap guide and then the 540 tap. And center drill. Always use a center drill or a starter drill of some kind. You know, there's a lot of ways of setting your depth for a blind hole, and one is to mark the bit, and you might be able to see the little green mark on there, but that's highly inaccurate. Also, you may come up or come to the work, touch off, which I'm doing right here, and then zero out your knee crank and raise your entire knee, and that's how you do your drilling operation. But one way that I found is effective, and again, touching off and looking up here at the depth stop, if I can zero in on that. You know, this is a removable type. Of course, you can use this one, but it takes you forever to thread it up. But I like to put the temporary one on like that, and this is a 5/16 square tool bit, but you could use a round drill bit for that matter, and just bring it up, and then you've got your then remove the bit, and you've got your 5/16 space. And just stop, of course. When you drill, you'll come down and touch the stop. Just for variety, I will drill this by the method of raising the knee 312 thousandths. So I've zeroed out the dial on the crank. And that's 100. 200. 312. And now I'm tapping at 540 using the tap guide. Until I feel the bottom. This is a tapered tap, so I may go in with a bottoming tap over at the bench if necessary. The center hole is done, so now for the steam ports. So I need to move 406 thousandths, and I'm looking at the digital readout, which is not on camera. So there's 406 thousandths, and I will center drill that. Remember, that's half of the 13/16 center to center distance. Then, rather than changing the tools, I'm just going to move the position, and I'm going to go 406 thousandths in the other direction, which is right there. Now this is the 3/32 bit, and I do not really know how deep to drill, because in fact you can see I drill a little ways and then there's going to be an angled hole drilled. So I'm just going to arbitrarily and capriciously decide to drill it 1/4 inch deep. So I've set the depth stop off camera. And I moved down 13/16 from the other one, and we'll drill this one. Now, this could all be done on a drill press, but I tell you, you'd really be severely handicapped by that. Looking at the actual casting here, you see that there's a clearance slot in there. I don't know what they call it, but it calls for a clearance on the cylinder as well. And you'll see it right there. And in the text here, it says that ought to be about 1/4 inch wide and 30 seconds of an inch deep. Now I find it a bit redundant to have it in both pieces, but there it shows it in both pieces. So I'm going to go ahead and do this just to kind of remain consistent with the drawing, although I certainly have strayed a little bit, if you will. So I got a 1/4 inch bit in there, and it's already set for the right depth, and I'll just take a pass. And that's all there is to that. And I'm going to take it out. Now I had to determine which is the top and which is the bottom of the casting, in fact, if there's any difference at all. And finally, through a process of deduction or whatever, I see that these two bosses here reminded me from when I was 16, so I pulled out the old number 9 engine, and I believe what they were for is it's a location for the petcocks if you were to include those in the project, which I'm not going to. So I will put that on the top, and I have thusly marked this, or I'll put these on the bottom rather, and this is marked top. I was just looking, and I put a temporary 540 screw in there just so I could assemble it like this. And I believe that the cylinder here, get in there, almost looks out of proportion, too large. And I know that they use this cylinder on several engines that are shown in that yellow book, including the vertical version of this. Well, that wouldn't make any difference, but you know, it just looks so from this direction so wide and large, but I guess it's all right because pictures of the finished engine look pretty good. So that's how it pivots or oscillates or swivels, and thusly the name wobbler. Now I'm still not done with this, and this is a rather stressful piece because we've got 6 holes to drill on each end. By the way, I don't know if I showed you this before. I don't think I did. But the bore that I achieved by reaming that is quite satisfactory, and it doesn't really need any polishing in my opinion. So that's ready to go. If you do have tool marks and it wasn't a sharp reamer, you can use a little emery cloth flappy thing that you make with a wooden dowel that I've used in other videos. So now I would like to complete the ports, those angular ports, because how is the steam going to get into the cylinder? Well, those little angled holes that I have to drill, and that's kind of a process that I got to think through, because the original ones, like in this, had cored ports. So let me show you one. I guess I forgot to tell you what the petcocks are for. If you're running it on steam, the steam will condense, especially when the engine is cold and the steam is introduced to the cylinders. There's going to be a lot of water, and the water needs to get out of there, and the petcocks were a way of releasing that water. You just open them up when you first start up the engine, and a lot of water comes out. So that's what they're for, but I'll be running this on air. And now, getting back to the steam ports, you really couldn't, or Stuart really couldn't cast those in because the core would be just so tiny if you can visualize it. But on a larger engine such as this unfinished one that my brother gave me, he bought it at a flea market, so I don't know anything about it, other than you can see here that the steam port here was cast in. Same thing on the other side, but you know, there's other holes. I don't know if you can see it through here or not. Let's use the flashlight here. Get in there. You're not going to be able to see it, but yes, you can. See the ports? But those are all cast into this big brass casting using cores the same as this hole would have been cored. And I told you I was a little disappointed that they didn't have this hole cored, but reading the text in here, they claimed that they did. And they said it only needs reaming. But, well, did they lie? Well, again, this was printed, when did I say, 1913. And really, I don't believe revised other than that nice intro by Tubalcain. All right, enough gabbing. All right, I've stalled long enough, and thinking about this, I'm tormented by how to drill these passages. And I finally came up with this method using my little Palmgren very narrow angle vise, and I've never have used this. It came from an auction, but it's so cute. Well, I've got the cylinder in there, and this is set at 40 degrees, again, which is kind of arbitrary, but I'll show you how I arrived at it here momentarily. But notice that this valve face is against the fixed jaw. Now, this will be done on the milling machine, but the first thing that has to be done is for a small flat to be milled there, easy enough. In other words, a place with which to start drilling that is flat and the bit isn't going to skid off. You can't just start drilling on something like this. It'll skate right off on you. But using this 3/32 bit here, just so you can visualize it, that's into the steam port that I drilled previously. And then if this is my new drill, and I believe, I got to look that up, I think it calls for 3/32 also, but I believe that at 40 degrees they're going to intersect at approximately the point that would be necessary, again looking at this drawing. It's just, and I will drill until I feel it break through. But can you see a little flat spot that's been milled there? But since the end goes in there, the end plate, the head I should say, that's going to go into 32 of an inch, so I don't want it to block this steam port. Alright, I'm going to go over to the Bridgeport now and just clamp this down. Alright, have a look at this outrageous setup. Again, this is 40 degrees, and that's an 1/8 inch end mill, and I'm going to mill just a little bit of a flat there, as I just talked about a few moments ago. I have attempted to locate the end mill in relationship to the bore in the y-axis. Well, first by eyeballing, but this is a 3/16 drill bit, so I have an equal amount on each side, but that doesn't have to be perfect, but that's how I arrived at that. That's kind of bagasse and bagash, but it'll be okay. Where's my crank? There it is. Very delicate cutter. That little flat is an 1/8 inch wide and about an 1/8 inch long, so I've got a little platform for drilling. And that small center drill just enough to start the hole. That's my 3/32 bit, and I'm just going to drill, hopefully, until the two holes intersect, and I should feel that when they intersect. But I must confess that my heart is beating rapidly. I wish I had one of those stupid little exerciser things that measures your heart rate. But I don't have anything that high tech. Actually, I don't want it either. That's it. I felt it intersect, and I don't know if it showed up, but did you see some chips coming out of the other hole? Right down here. The chips were escaping, so I know that I intersected. Yep. Great. I'm a happy man. But then again, simple things make me happy. Doesn't have to be a Cadillac. Alright, I'll do the exact same thing on the other side, and I'm not going to show that because it would be a repetition. I felt like Myford Boy there for a minute. Well, that's quite enough fun for today. I'll see you tomorrow when I continue and I start on the head. So, this is Tubalcain saying so long for now. Thanks for watching, and I'll see you on the morrow.